Good evening, students. Yes, is it audible clearly? So in the chat box, you just tell me whether it is audible or no. We will start with system of particles under rotational motion today. Okay. Okay, so let us start with this topic. So here you can see the first question. The moment of inertia of a circular ring of radius r and mass m about the diameter is. So here in this chapter you will study about the moment of inertia. So moment of inertia is denoted by the letter r. Then the moment of inertia is usually defined as what? In general, the moment of inertia, we define it as the product of mass and the square of the radius. Okay, so here for particular bodies like circular ring or shell, so different shaped bodies, we have the different formulas. Here it is a direct question. You will get a list of this moment of inertia formula for the different shape of the bodies. Here in this question, they are asking it for the circular ring. Okay, so what is the moment of inertia for the circular ring of radius r and the mass im about the diameter is? It is a direct question. Yes, if anybody knows, you can tell me. Here the options are given as 2 by 5 mr square, mr square by 4, mr square by 2, mr square by 12. Yes, option C. Yes, for the circular ring, option C is the right answer. That is mr square divided by 2. It is a direct answer. So the moment of inertia for the circular ring is given by mr square divided by 2. Okay. So next, let us see the next question. See the next question. A door 1.6 meter wide requires a force of 1 Newton to be applied at the free end to open or close it. The force that is required at a point 0.4 meter distant from the hinges of or opening and closing of the door is. So here they have given, that is, what is the force is required. Okay, the force is required to open that door. So here the door 1.6 wide. So door length ಏನಂತ width ಎಷ್ಟಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, it is given as 1.6 meter. It requires a force of 1 Newton to open that or to close that. Okay, so door ಅನ್ನ open ಮಾಡ್ಲಿಕ್ಕೆ ಅಥವಾ close ಮಾಡ್ಲಿಕ್ಕೆ ನಮಗೆ ಇಲ್ಲಿ 1 Newton force ಬೇಕಾಗತ್ತೆ when it is 1.6 meter wide. Okay, the force that is required. So when the door is 0.4 meter at a point of 0.4 meter distance from the hinges. So hinges means that is where the door is fixed. Okay, so if you see the door ಏನಾಗುತ್ತೆ, one particular point ಅಲ್ಲಿ the doors are fixed. Okay, so here the doors are fixed. So ಇಲ್ಲೇ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ, these are called as the hinges. So for this one, the force that is required at a distance of, so at a distance of, so total width is how much? This is 1.6 meter. So now they are saying that the force that is required at a point of, so at a point of 0.4 meter distance from the hinges. So illen fixed point ide, illinda 0.4 meter distance al tagondre, so e point inda, okay, so from this point to open the door, how much force is required? To open the door or to close the door, how much force is required? Yes, try this. Yes. See here, so this is nothing but it is a twisting force. So the twisting force is nothing but the torque. So as we know that the formula for the torque is given by torque tau is equal to force into the displacement. So here we need to calculate the value of the force. So force is given by force divided by the displacement. So for the torque divided by the displacement. So torque, they have calculated here. So the torque value is force into displacement. So first force ಎಷ್ಟಂತ ಹೇಳಿದ್ದಾರೆ, that is 1.6 is the distance and the force required is 1 Newton. So the torque will be 1.6 Newton meter. Okay, so now the torque is 1.6 Newton meter. So 1.6 Newton meter, and the distance, how much they are saying here? 0.4. So now let us calculate the force. So this is 4 ones are, 4 fours are. Yes, so here therefore the 4 Newton forces required for that. So the force required to open that door at the distance of 0.4 meter from the hinges, it is 4 Newton. So option D is the right answer. Okay, so copy down. Next question we will see. Okay, so simple question. So torque is equal to force into displacement, or the force into distance. Actually, force into perpendicular distance anta ಹೇಳ್ತೀವಿ. So first values in the torque and find out ಮಾಡ್ಕೊಳ್ಳಿ. Then with that torque, you can calculate the force in the second case. Next question, students. See the next question. The moment of inertia of a circular disc of radius 2 meter and mass 1 kg about an axis passing through the center of mass, but perpendicular to the plane of the disc is 2 kg meter square. Okay, so the moment of inertia for the circular disc of radius 2 meter and mass 1 kg about an axis passing through the center of mass, but perpendicular to the plane of the disc is how much? It is 2 kg meter square. Okay, its moment of inertia about an axis parallel to this about this axis, but passing through the edge of the disc is. So here first part al ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ, the moment of inertia value is given for the circular disc whose radius is 2 meter. Okay, so first ಇಲ್ಲಿ ಏನು figure ನೋಡ್ತಾ ಇದ್ದೀರಾ, ಒಂದು circular disc ನೋಡ್ತಾ ಇದ್ದೀರಾ, ಅದರ radius 2 meter ಇದೆ and mass is 1 kg. Okay, so when the axis is passing through the center, that time the moment of inertia is 2 kg meter square. In the second figure, what they are saying, it's moment of inertia about an axis parallel to this axis, but passing through the edge. Okay, hope so you are understanding the question. So with respect to this first figure, whatever the xy you are seeing here, here the radius is given as 2 meter and the mass is given as 1 kg, and the moment of inertia is given as how much? It is 2 kg meter square. In the second figure, what they are saying, so here the axis is passing through the edge. The axis is passing through the edge of the disc. So now what is the value of the moment of inertia? This you need to calculate. Okay, let us see how to do this one. See, so first the mass is 1 kg, the radius is 2 meter. For the circular disc, we know that. So for the circular disc, the radius, that is the moment of inertia is given by, that is for the first center axis, that is Ixy is equal to the moment of inertia is mr square by 2. Okay, so mr square by 2, and this value is already given. How much it is? It is given as 2 kg meter square. Okay, so now according to the theorem of the parallel axis, so parallel axis, perpendicular axis, we study the theorems in this chapter. So according to the parallel axis theorem here, for the edge line, it is given by x1 y1 is equal to. So according to the principle of the parallel axis, so the moment of inertia of the xy means the center one plus mr square plus mr square. Okay, so the value of this xy, the moment of inertia of about xy is already calculated. So here this is mr square by 2 plus mr square. So if you substitute the value, the complication will be lengthy. So now we'll substitute ಮಾಡೋ ಬದಲಾಗಿ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ, the formula we are substituting. So this is like mr square common ಆಗತ್ತೆ. Inside the bracket we have 1 by 2 plus 1, right? So half plus 1 by 1 will be how much? It is 3 by 2 mr square. It is 3 by 2 mr square. So the remaining values already we have. That is the 3 by 2, mass is 1 kg and the radius is 2. It's 4, square will be 4. So 2 ones are 2 twos are. So 3 twos are, it will be 6. 3 twos are, it will be 6. So now, therefore, here the moment of inertia about x1, y1 will be how much? It is 6 kg meter square. 6 kg meter square. Yes, copy down students. If any doubt is there, please ask. Yes, completed. Yes, next question, students. A solid sphere of mass M rolls down an inclined plane without slipping, starting from rest at the top of an inclined plane. Okay, so first you need to understand, here you have the inclined plane. So without slipping, first it is rolling. Okay, so the mass is given as M. It rolls down on the inclined plane without slipping. Okay, so here this will be a, sorry. So this will be an inclined plane. So here at the top, you can imagine a solid sphere. Okay. Next, it is starting from the rest at the top of an inclined plane. So initially, it is at the rest. The linear speed of the sphere at the bottom of inclined plane is. So the linear speed at the bottom. So at the bottom, what is the linear speed they are asking? The kinetic energy of the sphere at the bottom is. Okay. So at the bottom, the linear speed is given as v. They are not asking, they are saying it as v. Initially it is 0. At the end it is v. Then what about the value of the kinetic energy? Okay, we need to calculate the kinetic energy here. So see how to simplify this. See here. So the kinetic energy of the solid sphere. So the kinetic energy of the solid sphere, because it is in the motion. Okay. So motion alirodrinda, we need to apply the rotational motion formulas. So new half mv square, it is for the linear motion. It is in the rotational motion. So therefore here see the kinetic energy will be given as the kinetic energy of the translational motion plus the kinetic energy of the rotational motion. So for the translational motion means it is a linear motion. The formula for the linear motion is it is half mv square plus. For the rotational motion, the kinetic energy is given by what? 1 by 2 I omega square. So this half mv square, keep it as it is, plus 1 by 2. Then next here, that is the moment of inertia of the solid sphere is written as how much? 2 by 5 mr square. Hope so you are understanding here, students. So the kinetic energy they are asking, the kinetic energy is given as, it is the sum of the kinetic energy of the translational motion plus the rotational motion. For the translational motion, it is 1 by 2 mv square, half mv square, plus for the rotational motion, it is half I omega square. Okay, so this half mv square we are writing as it is, plus 1 by 2. I is the moment of inertia for the rotational motion, sorry, for the solid sphere. So for the solid sphere, the value is given as 2 by 5 mr square into omega square. 2 by 5 mr square into omega square, right? Now, so this value we need to simplify it. So keep the half mv square value as it is, plus. So this is 1 by 2. 2 will get cancelled here. Therefore, it will be a 1 by 5 mr square omega square. Mr square omega square. So half mv square plus 1 by 5 mr square omega square. So as we know that the relation between the linear velocity and the angular velocity is given as v is equal to r omega. It is v is equal to r omega. So therefore, this is equal to 1 by 2 mv square plus, here it is 1 by 5. At place of, we need to substitute it for what? That is omega value. So omega value, if I want to substitute, it will be v by r is equal to omega. So if I substitute here, you'll know e step alli, omega place alli, what we are going to substitute? 1 by 5 mr square into omega value is, it is v by r whole square, right? So here this will be r square. So r square will get cancelled. We will be having 1 by 5 m r square. Sorry, r square will get cancelled, mv square. Okay, so here you can see 1 by 5. We have only 1 by 5 mv square. So mv square common agatte. Mv square inside the bracket 1 by 2 plus 1 by 5 will be 7 by 10 mv square. So this is the value of the kinetic energy when the solid sphere is rolling over the inclined plane. Option D is the right answer. Yes, copy down. Okay, students, next question. See the next question. So in this question, they have given the value of the force. The F is given as F I cap plus 2j cap minus 5k cap acts on a particle whose position vector is given as I cap minus 2j cap plus k cap. What is the torque about the origin? So here we need to calculate the value of the torque. So very simple question it is. We just need to put it in a determinant. So see here. So two values are there. The torque is given as R cross F. So everybody knows about this one, how to simplify. So I, J, K will be the components here. So you just need to put it in the. So this is I, J, K. The coefficient of I in the first is 1. J coefficient minus 2 ಇದೆ, K coefficient 1 ಬರುತ್ತೆ. Similarly, in case of F, the I coefficient is 5, the J coefficient is 2, and the K coefficient is minus 5. Okay, so here what we need to do, hope so ಎಲ್ರಿಗೂ ಗೊತ್ತಿದೆ. When you are writing it I into bracket, you need to just leave the row and the column. So when you leave, just you need to do the remaining two cross multiplication. Right, so 5 2s will be 10, minus into minus will be plus, minus 2 into 1 will be 2. So minus baratte J cap ge. So minus J cap into bracket. So again, row and the column you need to leave. ನಿಮಗೆ ಗೊತ್ತಿದೆ ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. So I'll not go in detail here. So the last is K component. So when you take the K component, again row, leave the row and the column. That will be 2 minus of 10. So minus into minus will be a plus. So if you simplify here, 10 minus 2 will be 8. 8 I cap plus 10 J cap plus 12 K cap. If any doubt is there in any of the question, please ask. Otherwise, copy down. Yes. A rotating wheel changes angular speed from 1800 rpm to 3000 rpm in 20 seconds. What is the angular acceleration assuming to be uniform? So in here we need to calculate the value of the angular acceleration. Here we have the rotating wheel whose angular speed is changing from 1800 rotational per minute to 3000 rotational per minute in 20 seconds. So let us calculate the angular acceleration here, students. So first, when it is 1800, the initial angular speed is given by 1800 into 2 pi by 60. Here the conversion, that is angular speed we are calculating. So the angular speed first, it is rotational per minute irodrinda first convert ಮಾಡ್ಕೊಳ್ಳಿ. So 1800 into conversion factor is 2 pi by 60. So here 0 0 will get cancelled. 6 1s are 6 6. So here 2 is there, that is 60 pi, 60 into pi radian per second. The final angular speed will be 3000 into 2 pi by 60. So it will be 100 into pi radian per second. Okay, the time during which this change of speed takes place, that time duration is given in the question as 20 seconds. Okay, so therefore here the angular acceleration of the wheel is given by. So the angular acceleration of the wheel is given by, that is omega is equal to the initial angular acceleration plus alpha into t. So here we need alpha value. Alpha is the angular acceleration. So angular acceleration is omega minus omega naught divided by t. So the omega value is how much? It is 60, that is 100 pi, minus it is 60 pi, divided by the time is how much it is given as 20. So here if you simplify, it will be a 2 pi radian per second. That is option A is the right answer. Copy down. Is completed. Next question. See, a body is having a moment of inertia about its axis of rotation equal to 3 kg meter square. He is rotating with angular velocity of 3 radian per second. So here the rotation is equal to, it is 3 kg meter square. It is rotating with angular velocity 3 radian per second. Next, the kinetic energy of this rotating body is same as that of the mass of the body as 27 kg, moving with velocity v. Then what is the value of the v value? Okay, so here what is the question? Here the moment of inertia of one body is equal to, it is 3 kg meter square. It is rotating with an angular velocity of 3 radian per second. Okay. The kinetic energy of this rotating body is same as that of the body of the mass 27 kg, which is moving with velocity v. Then the value of the v is calculated as, see. So first write down the data here. The moment of inertia is 3 kg meter square. The angular velocity is 3 radian per second. And the kinetic energy of the rotation due to the rotation is, it is due to rotational motion is half I omega square. The mass is given as 27 kg in the second case. Okay, so we need to calculate the value of the velocity v. So the linear velocity, linear kinetic energy and a half mv square anta baritivi. So in the question they have given here 1 point, students. That is the kinetic energy of the rotational motion is equal to the kinetic energy of the translational motion. So the rotational motion formula is what? That is half I omega square, which is equal to half mv square, right? So you can substitute all the values here. This is 1 by 2. The value will get cancelled on both the sides. So leave it. The value of the I, the moment of inertia for the first is 3 into omega value is also given. It is 3 square is 9, which is equal to, in this case, second case, the mass is 27. V square, we just need to simplify. So 9 3s are. So that is 27. 27 by 27 will be 1. So this is V square is equal to 1. Therefore, V is equal to, it is 1 meter per second. V is equal to 1 meter per second, right? So option B is the answer. Copy down this. Yes. Completed. Next question. See, you just try that. See here, students, next question. See here, students, the moment of inertia for the rod is given as. So this also you just need to copy down this. The moment of inertia for the rod is given as, that is 1 by 12 ml square. Okay. When the same rod is bent into the ring of radius r, then, so here when it is bent into the ring, that time the L value we can substitute it as what? 2 pi r. Hope so you now know that one. Okay, so yavaga one wire athwa enadru one object irutte. It is in the linear shape. So when this length is bent in the circular shape, so this time the L is always taken as how much? It is 2 pi r. So remember this one. So therefore the radius we can just write it as L divided by 2 pi. This is the radius. The moment of inertia about its diameter is I dash is equal to 1 by 2 half m r square. So this half m, keep it as it is. R value from equation 1 we can substitute. So R value anna illinda substitute ಮಾಡ್ಕೊಳ್ಳಿ. Okay. So now here if you see the 2 square will be 4. 4 into 2 will be 8. So therefore this is 1 by 8 pi square into ml square. Howda? Now we have I and the I dash value. So I and I dash value is there. So when you take the ratio of I by I dash. So what is I here? I value is 1 by 12 ml square and the I dash value is 1 upon 8 pi square. So this is 1 upon 8 pi square ml square. So this ml square will get cancelled. So what is remaining now? The remaining simplification will be 2 by 3 pi square. 2 by 3 pi square. Option D is the right answer. Yes. ಯಾರಿಗಾದ್ರೂ ಆನ್ಸರ್ ಕರೆಕ್ಟ್ ಆಗಿ ಬಂದಿದ್ಯಾ ನೋಡಿ ಚೆಕ್ ಮಾಡಿ. So very important questions. Solutions and the questions please copy down neatly, or else again once again you can go through the same question and the solutions in the YouTube also. So please understand. So very easy questions and very important questions. Yes, completed. Next question. See here. Which of the points is likely position of the center of mass of the system shown in the figure? So here 4 points are given A, B, C, D. So half is sand and half is air. Which of the following is likely position of the center of the mass of the system as shown in the figure? So ಇದ್ರಲ್ಲಿ ಯಾವ center of point ಆಗ್ಬೋದು, ಯಾವ center of mass of the point ಆಗತ್ತೆ for this given system? Yes, little you guess, students here. D. It is option D or D point you are saying? Yes, D point is the right answer here, students. So D point, that is option B. So D point will be the center of mass. Yes, very good. So see the next question here. Three bodies, a ring, solid, solid ring and a solid sphere having same mass and same radius roll down the inclined plane without slipping. Okay, so three bodies simultaneously they are rolling here. You have a ring, solid cylinder and solid sphere. Okay, they starts from rest. So they are starting from the rest. If VR, VC and VS are velocities of respective bodies. So VR is the velocity of the ring. VC is the velocity of the solid cylinder. VS is the velocity of the solid sphere. Okay, so then see what they are asking here. On reaching the bottom of the sphere, okay, are velocities of the respective bodies on reaching the bottom of the plane, then so which velocity will be greater or equal, or whether it is less than the other one, that you need to understand. So three bodies, more bodies simultaneously roll down ಆಗ್ತಾ ಇದೆ inclined plane ಮೇಲೆ, ಆವಾಗ ಅದ್ರ ವೆಲಾಸಿಟೀಸ್ ಯಾವ ತರ ರಿಲೇಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಅಂತ ನೀವು ಇಲ್ಲಿ ಹೇಳ್ಬೇಕು. Yes, this also you can just guess it. See, here the velocity of the body at the bottom of the incline when it rolls down the inclined plane. So here the velocity of the ring is less than the cylinder, is less than the solid sphere. Means the solid sphere is having the more velocity, right? That is option C. Option C baratte. So first is cylinder, which is having the greater velocity than the, sorry, the solid. Sphere first, then cylinder, then the ring. Okay. Next question, students. Two balls are thrown simultaneously in air. The acceleration of the center of mass of the two balls when in air is equal to acceleration due to gravity, depends on the masses of the two balls, depends on the direction of the motion of the two balls, depends on the speeds of the two balls. Yes. So here the two balls are thrown simultaneously in air. When they are thrown simultaneously in the air, here the acceleration of the center of mass of the two balls when in air. Yes, that is option A. Here what happens? The acceleration of the center of mass of the two balls will be equal to the acceleration due to gravity. Okay, it is equal to the acceleration due to gravity. Next question here. See, moment of inertia of a body about two perpendicular axes x and y in the plane of lamina are 20 kg meter square and 25 kg meter square respectively. Its moment of inertia about an axis perpendicular to the plane of the lamina and passing through the point of intersection of x and y axes, interaction of the x and y axes. See here. So here the moment of inertia of the body about two perpendicular axes is given as x and y in the plane of lamina. So the value is 20 kg meter square and 25 kg meter square respectively. Its moment of inertia about an axis perpendicular to the plane of the lamina and through the point of intersection is, see here, the moment of inertia about x-axis is 20 kg meter square and about y-axis is 25 kg meter square. By the theorem of perpendicular axis, the moment of inertia of the body is given as, so this is perpendicular axis formula, that is ix is equal to iz is equal to ix plus iy. So L2 values kottidare, you can just substitute and you can write it as 45 kg meter square, option B. Next question, students. Two particles which are initially at rest move towards each other under the action of their mutual attraction. If their speeds are v and 2v at any instant, then the speed of center of mass of the system is, here the two particles which are initially at rest move towards each other under the action of their mutual attraction. Okay. Their speeds are given as v and 2v at any instant. Then the speed of center of mass of the system is, option C, option D. See, no external force acts, so the speed of the center of the mass will be 0. So here when two particles which are initially at rest move towards each other under the action of mutual attraction, both are having the different velocities, then the speed of the center of mass will be 0. So it is not depending on that. So center of mass mele aden depend agiralla. Okay, option D is the right answer. So last one question. This question we will do. Last one question here, students. See, the angular speed of a motor wheel is increased from 1200 rpm to 3120 rpm in 16 seconds. The angular acceleration of the motor wheel is, so what is the value of the angular acceleration? Yes, the initial angular speed is omega naught is equal to 2 pi into 1200 by 60. So the initial angular speed will be 40 into pi. The final angular speed will be 2 pi by 60, that is 3120. So simplify, it will be 104 pi radian per second. Already now idr mele questions ಮಾಡಿದೀವಿ. The angular acceleration will be omega minus omega naught by t. So omega will be 104 into pi minus 40 into pi by 16. So it will be 4 pi radian per second square. So option D is the right answer. Okay, students. So copy down this. We will meet in the next class with a few more questions on this chapter. If any doubt is there from any of the questions, ನೀವು ಬೇಕಾದ್ರೆ mention ಮಾಡಿ question number ಅನ್ನ we can discuss once again. If any doubt is there, please ask. Otherwise, we will meet in the next class. Okay. Yes. Thank you. Bye.